Good day, engineering thinkers, and welcome to another episode of Engineering Thinking by IK. This is a show where we inspire all engineers to come and think like an engineer, whether you are one or not. You have a place here. We have a fantastic guest with us here today. This is an individual, a professional with over 20 years in the railway industry. He is the country managing director of Alstom Transport Services Malaysia, Sendirian Berhad. But more than that, I'm going to give you a little bit more of a background of our next guest. Now, he was also the senior project manager at SCOMI Rail and also the project lead at MyHSR Corporation. If that wasn't enough, he was also the COO of Sapura Technologies. Now, our guest represents Alstom Transport Systems here in Malaysia, but you should know that Alstom, based out of France, is a global rolling stock manufacturing powerhouse. They have offices in Europe and North America and across Asia as well. They deal specifically with high-tech, high-speed, people transportation, locomotion, and signal systems. So we're going to learn a lot from our next guest, and we're very thankful that he's here today, despite his busy schedule. Mr. Ooi Kok Sim, thank you very much for joining us on the show today.
Thank you. Thank you, Sean.
Now we're going to ask Mr. Sim something very important for our first segment of the show. We like to call the journey. If we imagine engineers as superheroes that keep our world going, then every superhero has an origin story, a beginning. And so we're going to determine what Mr. Sim's origin story looks like. So Mr. Sim, could you tell our audience what inspired you to go on the path of engineering to begin with?
Unfortunately, my story is not like a superhero story. It's nothing fancy and things like that. But I believe that this probably happened in many families. So I came from a modest family here. And when I was a child, somehow I'm a bit more, let's say, hands-on or naughty. And anything that actually passed on to me by my parents, I'm going to tear them apart. So be it like even as simple as an alarm clock, a remote control car, the curiosity was always there for me to try to find out why such things actually happens. And that's even at the young age of like kindergarten age, like 5 or 6 years old. That's where I start to develop this kind of a curiosity here. I start to do a lot of so-called DIY at home. I start to changing not just simply the light bulbs and things like that, but I start to modify things at home as well. Changing so-called the electrical wiring and so on here. It does kind of give me some satisfactions when I'm able to actually to develop from nothing to something here. When it comes to the age of the college time, that's when I would need to start to choose a subject to study. In the so-called mid-90s, technology was not there. Information was not so easy to be found. There's no so-called internet, so-called availability. So I'm just following most of the people what they are studying. So in my class, secondary school class, there's about almost 2/3 of the classes of my classmates study in engineering. Hence, that I thought maybe engineering is the next thing. Because the 90s was the start of the dot-coms booming. So a lot of people were studying in IT, but then my batch of people were saying that perhaps too many in IT, now let's start to look into the engineering side of things. So that's how I started. But I got no reference. I don't know what to do, what to study, what means what, okay? No internet at that time for me to research. Around my family, my people around me, no one studied engineering at all. So in a very, very basic, traditional family, to us is engineering, there's only 3 types of engineering: electricals, mechanicals, and civil. That's probably the most basic fundamental. And somehow through the conversations with my parents, with the limited knowledge they have as well, they think that electrical engineering means like you're going to start to repair a TV. So you work into like a Philips, Sony, that kind of factories, that's your job. Mechanical would be like more towards the car, the automotive industry, and civil, you're like building buildings or bridges. So it's a very, very simple thing. And I thought, hey, that's not bad. I mean, that's something that I would like because those are the things that I always try to play around when I was young. But then come to the point of like, what engineering should I study? Because of there's so many of the choices there. So then I can't remember who told me, but there was one of the so-called wise men or the senior told me that said, if you imagine, or thinking back on your physics topics, which is the fundamental for the engineering, which topic of the physics that interests you the most? Or which was the topic that you were able to score very high because high score because you understand it very much. So I went back and looked at my whole so-called physics books and look at chapter by chapter, which are the portions that I find more interesting. And the part that I find it very interesting is the part about the gate logic, the AND gate, OR gates, that kind of thing. So I thought maybe that's what I want, and that's kind of lead me to the electronic studies here.
Well, Mr. Sim, that's an excellent answer. So we have a lot of audience members, I'm sure, that currently studying engineering in various faculties across the world too. What was your experience like when you finally got to the college level of engineering? Did you encounter a lot of challenges while you're going through? You said yourself that you were one of the first members of your family actually to go into the field. So that must have been quite overwhelming to begin with. How did you feel about your time in studying engineering?
So it's definitely a very, very high challenge because I underestimated. I thought physics is something that I'm doing well in school, choosing the so-called the gate logic part, which is the chapters that studying E and E is not a big issues. With mathematics is also one of my strong syllabus or subject as well. But the reality is it's not. The reality is it's much tougher when you go to the college or you go to universities. Things was completely different. So I studied my degree in UK. So the challenge is not only about the academic side of things. I was moving into a new countries, a place that I'm not familiar, family is not with me. English is a problem for me. I studied from a Chinese school. So all these kind of challenges are actually throwing me back. And that making me feel very, very, very difficult for me to overcome it.
So these are some really large challenges that Mr. Sim just shared with all of us. He came from a new basically a different country, didn't really speak the language too well, and also the syllabus was in an unfamiliar language as well. With, on top of that, a challenging course, which I'm sure some of you are very familiar with, engineering. So now we're going to ask Mr. Sim, how did you actually find the determination? How did you persevere through this? How did you come to terms with all these challenges and overcome them?
From a Chinese school background here, you are just used to forcing yourself to study. Try to memorize things, try to go through it, try to do all the past year papers and so on. Yeah. So that's in the way helping me to get through. So I'm not brilliant in my academic so-called time. I wasn't like a top class student. I wasn't like a first class student here, but it's enough for me to actually get through my degree. And that kind of lead me to my master degree and so on here. So that's kind of like I guess study hard. That's probably one way just to do it. But thinking back now, it's not just about study hard, it's study smart as well.
Study smart. Can you tell our audience what you believe studying smart means?
Study hard means you try to memorize things, you try to just to take it and without truly understand what's the principle about. Study smart means you're trying to understand what is all this about here. Using your own language, using your own wording here, try to explain it, which is something that thinking back, I didn't do it because I was using a very old method or very traditional method, try to study hard rather than study smart here.
So when you changed your approach, that really helped you understand the engineering concepts better.
So I only learned about this when I start to come to work. But during my study time, it was all study hard rather than study smart.
So audience members, make sure you keep that in mind. Mr. Sim just shared very important tips, especially if you're still struggling with engineering concepts and you think that just rote memorization is going to help you. Actually, it's not. And Mr. Sim has a lot of industry experience. He's a leader in the field. So he says you should study smart, understand the engineering concepts that you're studying. If you don't grasp the concepts, then you won't be successful academically or in practice when you come out to industry. It was very important for our audience to learn about your origin story, right? What inspired you? And now we understand now that actually Mr. Sim has curiosity about how stuff works. He was taking things apart when he was young, and he also had a lot of DIY projects, so he had the initiative and curiosity to pursue his passion in engineering. And we can see the fruits of his labors clearly have paid off, considering that he's a leader in industry. So that concludes the first segment of the show, and we're going to see you for the highlight. Stay with us. Engineering thinkers, welcome back. Thank you for joining us, and we're on to segment 2 of our show now. The highlight. This is where our guest, Mr. Sim, is going to share with us a case study from his time in the industry, of which he has a lot of experience. And so you're going to learn about some real life case studies and how to apply your engineering skills and engineering thinking to solve issues. But before that, an interesting fact, Mr. Sim was also the senior engineer at Eurostar after he concluded his studies. The journey from how he joined Eurostar as a senior engineer to where he is now as the country director, right, for Malaysia at Alstom. Clearly there was a transformation here from engineer to a business leader. So we're going to ask Mr. Sim what that change, that transformation was like. Mr. Sim, could you share with our audience, how did you make that change?
So when I graduated from my university days, and that time it was 1999, year 2000. So where it was the Asian economic crisis, and that was the time when a lot of my classmates, when they came back from UK, they couldn't get any job because the impact on the economic crisis was more towards the Asia rather than the Europe. So I thought maybe perhaps it's better for me to stay there, find a job, and working there as well, which I did, and I've actually submitted so many CVs, almost close to 100 CVs or job applications here, in order to try my luck. At the end, I've got 2 interviews, and out of the 2 interviews, one actually hired me, which is Eurostar. So studying electrical electronics engineering, first thing come to my mind would be like, do I want into the telco, the telecommunications? At that time was just going into the 2G kind of network and technologies. Do I want to go into the power, into the power sectors, semiconductors? So these are the 2 or 3 kind of like main industry that most of my classmates coming out from the E&E studies, they will be venturing into. Unfortunately, I didn't get any of those. I applied to many of these companies, but I didn't get. Then I started to try like in oil and gas, and any other industry. So long there's a word of like, hey, they're looking for engineer, that I started looking, because I know that being a foreigner to work in UK is not going to be that easy. It's not something that I can just walk in and try to get a job. Unlike if I come back to Malaysia, whereby nationalities is not an issue. When I say nationality issue, it's because of this work permit required for a foreigner to work there. So I was very, very lucky. I was given this opportunity to work for Eurostar, which is a high-speed rail between London and Paris. I thought, let's give it a try. Even though railway was not a cool thing in Malaysia at that point in time, in the 90s. I mean, people were still thinking, when I told people like I was working for a railway or Eurostar, first thing first they say, well, KTM, and back then the KTM it's not like the today is like the ETS to go to the Penang. It was still a very old train set. Some of the trains coaches are non-air conditioned, still using the fan. The toilet is something like you can still see on the track when they're okay. That is the scene of a railway back in the 90s. So I work in Eurostar in UK here. That was thinking like, okay, my career maybe is going to be more suitable to the UK, because Malaysia at that time railway was not fully developed at all. And I thought, if I come back to Malaysia, I have to change the industry. Without thinking much, I accept the job, I start my journey. And that journey led me to about almost 10 years to work for Eurostar, from a graduate engineer all the way up to the senior engineers. Then at the point of like, I decided to come back to Malaysia. I mean, for many reasons, family definitely is one of them. And I thought, and at that time, the Malaysia railway, it just started to be booming. So we can see that the national policy or the different leaders will have a different so-called focus point. So in the 90s, during my time there, it was still under the Tun Mahathir time. He was more into automotive, to the highways, automotive. These are the industry that was actually booming. But come to the point of Najib as the Prime Minister, he started a lot of the railway project here. So this is the start of the booming of the Malaysian railway industry. So I came back, I joined a local company called SCOMI, who is the monorail manufacturer. Today, like the KL monorail is actually manufactured by SCOMI. They also exporting out their monorail to India and also to Brazil as well. So it's considered quite a good local champion company who are able to venture into the international scene here. So there onwards, I start to move to the different, still within the railway industry, but different sectors. And one of my very good memories is actually working for a government entity called MyHSR, which stands for the Malaysian High Speed Rail Company. So this is a Malaysian company who actually, they call it the project proponent for the high speed rail between KL to Singapore here. So my role was also including like project delivering the entire so-called the planning of the so-called the high speed rail. Yeah. Then from there onwards, I move on to Sapura and later now. So my transition from engineering to management is more from the moment I came back to Malaysia. So I started my 10 years of a technical or strong engineering in Eurostar, but when come back to Malaysia, it just happened that the opportunity was more leading me towards the project management, towards the management there. I know as well that when I was in Eurostar, at a certain point of time, I know that my interest is more towards the management. So dealing with the people, the overall, the coordinations, and the money part of the things, and so on here. So the larger portfolio or the wider spread of the overall, that was more of my interest. Hence, I kind of like transforming from like the technical role into the management role.
That's fantastic. Now, to our audience listening and watching, this is very important. So it's not just that you have to remember formulas and all this technical stuff when you sit down for your engineering exams. Remember that there's a whole world ahead of you. And there's so many different skills, like Mr. Sim mentioned. His transition from the railway all the way to the boardroom had so many parts of his milestones where he had to pick up different skills. And he mentioned things like managing people and leadership. We're going to talk a little bit about that as well, obviously, in this episode. But remember, you have all these opportunities ahead of you. That's not just solely just on the technical side of engineering. There's other aspects as well that you should consider, like Mr. Sim clearly has, and it worked to his benefit. So now that we know that Mr. Sim has had this amazing journey of going from the railway straight to the boardroom, now we're going to ask him to share something that we've been waiting for, the highlight of today's episode, which is a case study. So Mr. Sim would like to invite you to share with our audience members a case study from your time in the railway industry.
Okay. The case study that I would like to share is one of my time in MyHSR, which is planning for the alignment between KL to Singapore. So on a layman terms, what you do is like, you open up a map or you use a Google map today, you draw a line, KL, Singapore, straightest line. That's probably the shortest route. That's probably the easiest way and probably enable the train running at the top speed at a very, very short of time. However, things is not as simple as that. You have to take into consideration of many, many aspects as well. So one of the aspects will be from the cost angle. So if you draw a straight line here, the alignment may be passing through some of the area where it's going to be costing more to build the track. Example, hilly area where there's also like rivers and so on here. If you reroute a little bit, like instead of going through the mountain, but you go around the mountains, that's probably will make it much cheaper as well. So that's one of the elements you start to put into the considerations beside the so-called the technical angle here. Then there's also like other challenges like from a technical angle as well, whereby certain soil is more suitable, soil as in the ground, certain soil is a bit more softer as well. So you, again, rather than treating the soil or make it more hardened, you go around it, example. So that's the technical challenge angle. Then you start to add in other angles like, for example, environment study. So are you cutting through a forest reserve here? Can you avoid it? Can you go around it? How many habitats of like animals, wild animals that you're actually destroying? So again, that's put into the considerations. After that, there's also a social impact that you have to take into considerations. Passing through, example, if you are, this is like a kampong or village or a taman here. If your alignment passing through right smack in the middle, the impact of the social will be much huge compared to if you go to at the fringe of the so-called the village of the residential area here. So when all these elements they start to take into considerations from the environment angle, from the social angle, technical challenge angle, cost angle, it's a different story altogether. The alignment no longer be straight. The alignment will be like going left, right. So we can see this in many mega linear infrastructures that we see today. None of our road is actually, if it's so easy, we can just draw a line. North-south highway, if you look at the map, it's not straight line. It's go left, right a little bit for many reasons. And those reasons are something that is unavoidable, be it from a cost perspective, be it from the technical challenge, be it from the social and so on. Yeah. Of course, there's other mean as well, whereby there's a certain socio-economic development angle as well. Example, stations. So when the stations put it into a certain township or certain area, that area will be boom. Okay, so you purposely kind of swing the alignment to a certain area so that that station will be able to develop the local area as well. So with this, then that's become very challenging, whereby solving supposed to be a very simple technical so-called challenge, now because of your take into consideration of many other things, it becomes like a huge task, because there's so many area or so many angles that you have to take into considerations.
Wow. Did you get all of that, audience members? Who would have thought just designing a railway system from point A to point B had so many challenges? But now we're going to ask Mr. Sim to elaborate a little bit on all the different challenges he's mentioned, because I'm sure you're curious too. So, Mr. Sim, you mentioned that obviously if it's a high-speed rail, you want it to be as straight line as possible. That makes sense because you want to achieve the maximum top speed. With all those different challenges, social and environmental and even the physical challenges, obviously it's not possible to have a complete straight line. I think that's quite obvious. So for the technical challenges, how did you use sort of your skills and your experience to overcome, say, the inability to go through like straight through a mountain? Like what compromises or what adaptive technologies or strategies did you use to overcome that?
So, I mean, thanks to technology as well, there's today's in the market, there's many so-called software or technology that are able to overcome this kind of a challenge here. There's also like a software whereby they can actually analyzing like different routes or different options of the route here. So if you go for here, what kind of structure would it be? Would it be a tunnel? Would it be elevated, like a bridge? Would it be on the ground? And then so on here. So that will also giving you some indication in terms of cost, what will be the impact, what will be the technical challenge here. So you use the technology as much as you could, but at the same time, you also need to go down to the site yourself. You have to do the site recce, look at the area, look at the issue, because the computer or the software doesn't tell you everything. You have to take into consideration of like the impact on the people social, like say social as well. Yeah. And one of the very tough challenges to deal with the people emotions. So we have to go to the ground. So when we come up with the alignment, or we call it the corridor first, without telling that, so the corridor is about 500 meters wide. So we are saying that, okay, we are reserving, or we are looking at the alignment will be swinging somewhere around these 500 meters. Of course, if you are the homeowner or you are the landowner here, you start to feel worried that, hey, my house will be taken. So that would be something that they will feel very emotional about it. And there was like protests. There will be like people like we have to have a dialogue with the people as well. Just to say that, look, the alignment, even though it's like passing through, is still like 200 meters away from your house. Like we are just putting a 500 meters here just because of we want to look at all the possibility within the 500 meters. But the actual alignment most likely will be on this side of the so-called the land area, but not onto your, let's say, cutting your half of your village here. So those are the emotional part is something that it's not about study anymore. You don't start, it's not about like engineering study that how do you deal with the emotion of the people. So this is something that we have to learn, we have to try to deal with it. We have to have empathy and sympathy as well.
Wow. Now that's a very important lesson that, once again, Mr. Sim didn't mention technologies, and obviously in engineering you're going to use technologies and utilize all of that data points and surveys and scanning results. But Mr. Sim mentioned something very important. He went down to the site and he spoke to people. He spoke to the individuals in the community that represented the interests of that community, who had very real concerns. This was their property, this was their land. And so Mr. Sim mentioned people skills. And this is not something maybe that is very obvious because it might not be covered in depth or detail in engineering school, in engineering faculties. So we're going to ask Mr. Sim a little bit more about how he manages individuals and how he connects with communities to make this project a success. So, Mr. Sim, could you perhaps share some of your strategies? How do you communicate your intent and to show people the socio-economic benefits of the HSR program?
So of course, we need to explain or to address their concerns or bring in the unknown to them. Like what do they don't know about the benefit of the high-speed rail, or what they think is the bad thing about high-speed rail, where it could be just a myth. For example, here people will think that having a big infrastructure like a railway passing through your home will create a bad omen, or or something bad to your health and things like that. So, there's no scientific proof or any medical proof that that's the thing. Of course, there will be other concern would be noise, which is true. I mean, that's going to be a noise area here. So, we will have to address all these issues one by one here. There could be a traffic issues that they say that, hey, when you're cutting through let's say the road here, my traffics will be make it worse. Some is even like the drainage issue, whereby because we do see from time to time where there's a certain large infrastructure has been built, the area which never had flooded become flooding area. So these are the things that we need to start to look into. What's their main concerns? What some people, it's just as simple as, hey, let's say we are unavoidable and we have to cut through a certain, let's say the plantation land. Okay, they will say that by you cutting through, I can't get to the other side of my plantations, or the other side of the town, or so on. So we have to look at, okay, we can build like underpass, underneath the railway, bridges, things like that we can actually try to connect. So we need to understand what is their concern most, from a social angle, from a health angle, from any other angle, and some as simple as compensation angle. So like, how much do I get? If I lose my land or my house here, do I get enough compensations to buy another piece of land somewhere else? Similar size, similar things like that.
So, Mr. Sim, would you agree that not just having empathy and people skills and people management skills, for that matter, having negotiation skills would be important in this context too?
Definitely. So this is where, when it comes to the negotiations, it's not just about with the people, like let's say the community that were affected, but a negotiation skill, it could be with at work level where contractors, your consultants, where you have to come, there's a contracts where you want to award and you want to negotiate on a certain pricing and so on here. Those are the things that it is actually part of a skill set, at least for me now, moving into the direction of, to the position of a management.
So viewers, keep that in mind, negotiation skills as well as people management skills. So we're slowly adding on to the list of critical skills you need when you join industry, and this is true. And Mr. Sim will agree with me here that, but it's also exciting for all of you listening right now, watching, to be able to learn these skills and develop them for the future. Now, speaking of the future, Mr. Sim clearly has a lot of thought about the environment and environmental engineering when he did his HSR project. So we're going to ask Mr. Sim, why is environmental engineering so important for a railway project like this?
This is for future sustainability. Like if we don't protect or don't take care of our environment today, when do we gonna take care? If you look back at the so-called the history of our mankind, I think there's a lot of damage started since the industrialization's time. In the 19th centuries, where we start to have cars, factories. These are the things that we maybe at that point of time we don't have the knowledge about. All these things that actually lead into the so-called the harming of the environment. But today, with the knowledge that we know, with internets, with all the information that we can find anywhere, we know that this is going to be harmful. So it becomes super important that while we are building for future, we also need to protect our future as well.
I see. Fantastic answer. So keep that in mind. Engineers, when you go out into the world, you're going to be working on some pretty big projects. But remember, if you're building for the future, the environment should be part of that future too. Now, Mr. Sim also mentioned socioeconomic factors. Not something we think about when it related to engineering, right? But it's true, and in fact, in the United States, it's been found that cities with good public transportation access actually have greater vertical mobility in terms of their standards of living. So if you've got a train station or bus station close to you, it's actually pretty good for your neighborhood. So we're going to ask Mr. Sim what the impact has been in his project and in his experience with railways and stations specifically. So, Mr. Sim, my HSR obviously planned to have stations in certain towns to help the economy boom. Did you see this happen?
Yes. So this was a very main topic while we are designing for this or planning for this high-speed rail here. I mean, there's a lot of questions asked by public, even politicians as well. Why do we need a high-speed rail? We have a KTM today. The KTM is also serving from KL to Johor. Just maybe may not crossing to the Singapore. At least that's serving the majority of the alignment here. But think about it. Where is the KTM alignment today? If you look at the peninsula of Malaysia map here, our KTM alignment is actually towards the inner part of the land, which means like it's not at the coastal area, right smack in the middle, especially coming from the Gemas onwards. Yes, from the KL side, you go to the Seremban. Okay, there's no station in Malacca. The Pulau, the nearest one is near to the Tampin. After that, swinging to the Gemas, going down straight in the middle of it. But why? Why was KTM alignment is in that route? Do you know?
No, please tell us.
Okay. KTM was actually designed 100 years ago by the British. Okay. At that time, it was not meant for passenger services. It was more meant for freight services. So we have all our palm oil plantations, like all our rubbers and things like that. So serving the inner or the middle part of the Johor here was meant for to transport all the goods rather than people. So if you look at our Malaysia population density, majority of our population density is on the west coast rather than inland. Or first of all, it's coastal area. Both of the coastal area comparing to the inner part here. If we use KTM today, the social economic so-called enhancement does not bring the so-called the same impact. If you purposely build a line that are actually closer to let's say the biggest town. So the alignment at the time, we were being given a task to say that at least each of the state will have one stations. And Johor being the longest state among the whole alignment here, we will try to giving more than one station here. So ultimately, the station that has been decided was, after Kuala Lumpur, was Putrajaya, Seremban, Malacca. Then coming in Johor was in Muar, Batu Pahat, then Iskandar Puteri, which is the new township or the administrative city of the Johor. So we know that these are the areas that they will have more populations to be, or socio-economic, social activities to be there. And we want to bring the alignment. So if you are a traveler today, would you want to, let's say, if you want to go to, let's say, Muar, which is on the coastal line, would you go to Kluang, which is in the inner part, and drive an hour and a half to go to Muar? You find that this is like, it doesn't make sense. If I take a train 1 hour and then drive another 1.5 hours, I might as well drive from KL to Muar. Even taking you 3 hours, you think that it's still better. So we got to bring the convenience, we got to bring that mobility to the people, whereby people, when they go to the so-called to the town or to taking the high-speed rail, it must be something that where they can bring into the city very, very nearly. However, there's another coin of the story or something that you have to balance as well. As much as you want to bring the stations to the so-called the right smack in the city center, but at the same time, putting a big station in the city center, you're unable to develop the surrounding.
Right, because the city center is already quite well developed, I assume, right? So there's not much opportunity there to lift the standards.
Correct. So this is where, if you look at Europe, you look at China, majority of the train stations are now at the so-called the new township of the place. So let's say if you're going to put into let's say in the Batu Pahat, it won't be in the Batu Pahat town center. It'll be something like 5 kilometer away, 10 kilometer, still within 15, 20 minutes of driving. But you put it into a new area, you can start to develop the entire area as well. So you want to bring as close as possible to the so-called where the population are, but at the same time, you need to have a place whereby there's sufficient space for you to develop the entire area around it as well.
Incredible. Now, to our viewers out there, keep in mind, socioeconomic factors like this is huge for the nation. Smaller towns and smaller villages like this, they get the sort of capillary effect of the benefits of having mass transit move through their towns. So this is actually a very big development. Now, here on the show, we like to highlight the impacts that our guests have made. And so we've heard from Mr. Sim about the alignment of this project and all of the different factors he's had to consider, right, to get this project underway. So we want to ask Mr. Sim, how many riders have actually ridden on his projects? How many passengers have you transported by estimate in Malaysia?
So unfortunately, this project did not take off. This is a very, very sad news. So the plan, originally, the plan was supposed the construction to start in 2019, and the train will be in service by 2026, which is just another 2 years from now. But because of the change of priority of the government, and also I believe this as well, where we went through a very, very tough and difficult time where COVID was just a few years ago, and the entire focus from the government is more of how can we build the economy. Okay. Not saying that this project is completely out of the planning, and the government have said that they still see that this is one of the projects to be revived. However, the priority for now is not on the high-speed road for now. That we're giving other priority first. We do see that it is something that you cannot ignore or cannot just to say that, hey, this is not an important thing. I mean, look at China today.
Sure.
They started with so-called the tier 1 city. So China, when they built the high-speed rail, it started, the first line was Tianjin to Beijing. It's for the 2008, the Beijing Olympic. Yeah, that was the starting point. Today, 16 years down the line, they have built the longest high-speed rail network in the world. And if you add up the rest of the world, it is still less than 30% of the total China network. So all the China first-tier cities, second-tier cities, even third-tier cities now are equipped with a high-speed rail station. And they know that with a high-speed rail station, you were able to bring more economic into the city. And that's kind of bring the simulations to the country's economy as well.
So that's very important, right? So the high-speed rail project didn't manage to take off, unfortunately, because of different policies from the government, of course. But however, it goes to show that the amount of work it takes just to design a railway project is intense. So many different factors to consider. But let's ask Mr. Sim, if this project actually did go ahead, how many people would it have served, hypothetically? Can you share that with us?
So we were looking at the potential ridership, and I remember that, of course, every starting point of a new mode of transport will be very low because you're a bit skeptical, you don't know whether it's trustable or not, you never used it before, you don't know the benefit of it. So you tend to go with the mode of transport that you're more familiar. Example, your own car, flying, and so on here. Gradually, you start to move. So typically, the ridership will become stabilized or back or on the tracks. It's probably about year 5 to year 7 onwards. So we do see that by the time of year 10, they're probably going to be a yearly ridership of 18 million passengers.
Wow.
So just to give a comparisons, KIA today, the whole KIA 1 and 2 is about 50 million passengers per year. So the high-speed rail alone will take almost 1/3 of equivalent of a KIA size.
That's incredible.
Yeah.
That's, once again, that's the sort of project that you want to be involved in as an engineer, right? And you're going to want to fight for plans and projects like this to actually go through because they're going to impact so many people. 18 million people is an incredible amount of riders and passengers to be moved every year, right? Annually, right? So this is also another important thing we want to highlight in the show is that sometimes projects don't go ahead, and that's quite normal, I think, right? Because of a variety of reasons, financial or technological, whatever it is, or in this case, policy-wise. But another thing I think is important is how do leaders in industry like Mr. Sim actually approach government leaders and people in power to actually pitch the idea or actually sell the idea that this can actually impact 18 million riders in Malaysia. Can you imagine that if we had this project? So now we're going to ask Mr. Sim, now that he shared with us his really big picture view of high-speed rail here in Malaysia, we're going to ask him what are the kinds of people he's looking for as a business leader and the kinds of engineers that are required in Malaysia to build this nation into a better one. So, Mr. Sim, what are perhaps 5 qualities that you can think of to make this complete package of an engineer?
First thing come to my mind will be someone that are able to be agile, flexible. As you can see that my own journey, I started as I studied electrical engineers, but I end up working on the mechanical field, or working on the environment field, socials, all these things that was never thought in my so-called my academic time. So you got to be able to be agile and adapt to different environment, different topics, different peoples, different challenge. So agile, that's probably my number one. Number two to me is about your people skill. Unless today I'm working on something like a research and development, like very, very technical thing. I'm dealing with so-called the equipments, the machines, but most of my job today are dealing with peoples. Be it, there is the example that I was given will be like community, people, affectors, just like a normal auntie and uncle in the community. Or it can be a business people. I had to do presentations to the governments, like to the state government, to the chief minister, so forth. So all the state governments from Selangor, Negeri Sembilan, Melaka, and Johor, I even presented to them, presented to the Sultan of Johor. So all the stakeholders here. So the people skill and the range of the people skill can be a normal people to a very important people. The third I was thinking would be someone that are determined, someone who never say no, or oh, this is not my job, I'm only doing this is not my role here. Your personality, how do you take on the jobs? Because especially in the railway industry, or my industry here, it's a very, very small industry. People know people. All they need to do is just give you a call and say, hey, you work with who and who before. How is these people? How is this person? And if your character has always been very calculative, very not able to support, it's very tough for you to move up the rank as well. Yeah. And of course, the being an engineer, you need to have a problem-solving skill. Everything is a problem. Everything is a challenge. So it's just that the challenge is not. It may not be technical, like using a formula, using a certain inventions to solve the problem. And the problem can be in many, many forms. And that problem-solving skill is the fundamental, is the basic.
You did hear what Mr. Sim had to say about some of the qualities he's looking for. And a lot of this is not in your syllabus, probably. It's not in your textbook. Okay? So don't go looking at your glossary or index page for this. This is something that you have to learn on your own. Or perhaps if you join an organization, then you have to take the initiative. You have to volunteer yourself. Now, Mr. Sim said that he's looking for people with determination. All right, determination. So even if it feels uncomfortable, especially if it feels uncomfortable, try and take on those different roles. Try and experience something different as an engineer, right? Yeah, of course, when you guys go out and work in the real world, or perhaps some of you are already professionals, you're going to be there to solve problems. That's what people pay engineers to do. But there's so much more to the world of engineering. Okay, Mr. Sim also mentioned people skills. And earlier we mentioned skills like negotiation as being important too. So now we're going to ask Mr. Sim, how did he learn all these different skills, right? How did he actually come to be familiar with these things that are not in your textbooks, probably, right? So Mr. Sim, actually, how did you slowly develop your skill set, especially for communication skills?
This is not just limited to communication or people skill, but even leadership skill as well, in general. So what I do here is I learn from let's say my line manager. My Sifu is like all my line managers here. So every line manager that I had, I always learn something from them. They may be good at certain things. So for example, in my Eurostar time, I had this wonderful line manager who probably today he's about in his late 80s and he's still working. And he's a techno enthusiastic. He's the one actually to do a lot of technical findings. He's a true engineer. Let's put it this way, in the words here. I learned a lot about the technical skill, problem-solving skill from him. That's where he's good. But that's what he's good at. Moving on to the second companies, then I start to learn about project management skill. There was a seafood where we have been delivered in many railway projects, not only in Malaysia, but Singapore and a few other countries as well. So I start to learn from him how to deal with people, how to deal with timeline, how to deal with contractors, and so on here. Moving on to my HSR, then my line manager is a strategist. So he was the one actually doing a lot of strategies paper to the government, to the ministers, and so on here. So I learned that from him as well. So all these here have actually built who I am today. Okay, they are good managers. They are, let's say, not so good manager. But what I learned is I always take it a bit more positive, whereby the good one you learn and you try to implement it. The not so good one you learn and try not to implement it.
Yes.
And you remind yourself that, hey, these are the things that if me being a staff, I don't like it, meaning I shouldn't be practicing this into my own organization cultures, you know. So that's how I learned. I mean, from the people, every time when I move into the new organization, I start to learn that, you know, who is my role model and what can I learn from the persons.
Fantastic. Now, hopefully you guys got all that, and that's certainly very enlightening, right? So learn from mentors.
No, mentors. Yeah. A mentor doesn't have to be formal. A mentor can be someone like who are your work colleagues, who are your, let's say, your line manager, work colleagues, or even someone, you know, other department HOD as well. But it does bring you that kind of inspirations, you know, the things that, wow, I can learn something from the persons.
Fantastic. So keep that in mind. Mentors, very important. Learn the good lessons, apply the good lessons, and whatever's not so good, just leave them beside. Now, Mr. Sim did mention something that is very important that we've covered on the show previously, also project management skills. And how do you manage projects successfully, right? So we're going to ask Mr. Sim for some quick tips here. You're going to be handling projects when you guys and gals go out to the workforce, and this is an important skill to have. So Mr. Sim, what are some sort of tips you have to have a successful project, engineering or otherwise?
If you go through the textbook project management, they can tell you about three things. You know, it's about cost, time, quality. These are the typical thing. But in my own experience, people is the fourth one. Again, you can't run away with people, because as much as about money, as much about quality, about timeline, if you don't know how to manage people, none of the three will work. The fundamental to me, and majority of my time today, or I would say 80% of my time today, is dealing with people. All the issues come from people. Engineering is actually a very, very straightforward.
So the project management software is not going to be able to solve all of this by itself, is it?
So it's about how you deal with your client, how do you deal with your contractors, how do you deal with your colleagues, and so on here. The software is just helping you, the technology is helping you to execute it, but the fundamentals, the success of a project management, to me, is still about people. You need to have a good team. How do you have a good team here? You need to empower your team to do something. They have to have accountabilities. So if I'm being a very rigid, micromanaging leaders, my team will not able to deliver a result to me, because everything is still have to be according to my say. So I don't give it. So it's like sometimes when I start to moving up my rank in my career to become a leader, I see the similarity being a leader and being a parent. It's very similar, whereby it's like our children. If you don't trust them, you don't give them the freedom, you don't give them even the right to do it themselves, they will never learn. I mean, take example, my children, they start learning cooking by the age of 8 or 9. Okay, they know how to like switch on the gas, they know how to cook and things like that. But I know a lot of parents will never allow their children to do so, because they say, hey, what about if there's a fire, there's things like that. But you never try, you never know. That's the thing. Similarly for the working environment as well. If you never allow your staff to able to or empower them, let them run them on their own, of course they're going to make mistakes. You know, it's a human nature. Things will never get right at the first place. You just have to be able to recover it. How do you deal with it? Similar as our children, you know, like they were always gonna to like make a mess in the kitchens. It's about how do you clean up later. But during the process, they learn, and later on they become a better and better. The mess is getting smaller and smaller, or the mistake getting smaller and smaller.
So you would say that good delegation skills and trusting and building a team and empowering them actually makes them more independent, makes them more effective in projects, in engineering projects, for example. So to our audience out there, right, it's not just about the time, cost, and the deadline, which is obviously important for any project, but it's the people. Never forget the people and trust your team. Build strong teams, network, connect with them. And that's how you gain success in projects. I think we learned a very important lesson from the case study and from Mr. Sim's wonderful tips on leadership. Engineering thinkers, welcome back. We're now at the creative section of our episode. And this is where we're going to ask our guest about his vision of the engineering future, perhaps for railway projects and more. We'll also discuss technologies, especially emerging ones like green tech, right? So this is an incredible chance to hear from an industry leader and also how your work in the future are going to impact lives all across the world. So Mr. Sim, we're going to talk about green tech. Actually, your global CEO, Henry Lafarge, actually mentioned that the acceleration of sustainable and green transportation technology. So clearly, Alstom is looking as a global leader in rolling stock, right? How can they impact the world with green railway technology? I want to ask you just how that's being done and why it's important.
So if you look at the history of railway here, I'm sure you have seen it, like some of the so-called the movie where the ancients in Europe, where railway is actually a steam engine railway. Where they were doing the charcoal, they were putting into the burner and then creating the steam, and that's how they push the engine. That was the start of a railway technology. And gradually, in the last 100 years, it started to become we call it the electric. It went from the so-called the steam engine into the diesel. That means you're burning the diesel oil here, and then in the last 100 years, they're now into the electrifications. That means all our trains are electrified. And today, is this it? Is this the so-called the latest technology? Of course, it's not. There's more and more greener technology as well. We know that we can't avoid so-called electrifications or electrics to power it. But what kind of power is greener? So one of the very success story today is about using hydrogen cell, a power from a hydrogen. So this has become the next big thing for us, or for the railway industry as well. So all the railway companies or manufacturer of the rolling stock have started to go into the research and development of this. So Alstom is the same as well. Certain company are more into a metal trains or certain to a trams. So Alstom, we started with a commuter trains, a long distance commuter trains using a hydrogen power. And that's become a very success. And we became the first rolling stock company who actually have a product in operations in Germany. So this will become the test case, for the industry, that we are now able to use a hydrogen cell to power up the trains. We are no longer relying on diesel or electrification. We're using the wire throughout. Yeah, that saves a lot of money as well, because imagine this: if a line is hundreds and hundred kilometers, you got to build the electrifications or the power supply throughout 100 or over kilometers as well. So now that the train is actually self-powered through these hydrogens, and this will able to save money, environment, more friendly as well.
Wow, hydrogen fuel cells for trains.
Yes.
Because we heard about it in cars previously, right?
And they're now moving into trains now.
Right, so listeners, hydrogen fuel cell in trains. So these are just some of the innovations that you're going to be a part of in the future as well. Now we're going to ask Mr. Sim for what other technological developments he's a part of or interested in, and perhaps how different it has been from the time he joined Eurostar till now. So Mr. Sim, what are some emerging technologies that you're excited about?
You see, the technology advanced so fast that we're no longer relying on doing things manually. A lot of things that can be done so much more efficient with today's technology. I'll give one example, and this is something that it was kind of thinking back. 20 odd years ago when I started, I would never dream that this can be the situations in the future. So when I was an engineer in Eurostar, one of my placement is actually to work in the shop floor. That means where I repair the trains. And how do we do it? Meaning when a train arriving at the depot, so I have to go to the, let's say, a printer, printing out a list of activity that I need to do as my inspection list. Okay, so let's say got it, walk through the trains and start to recording it manually. That means whatever that I see, oh, there's a bolts here, maybe there's a losing port, I have to replace the bolts, something, or brake pads, these come to the minimum. So I've kind of like, you have to send people just walk through the trains in order to writing down things. The trains that I work on was a 400 meters trains. Okay, it's a very long train. Imagine this, if I forgot something, my pen, let's say halfway point, no more ink. I have to walk down another 5 or 10 minutes, down to the office, get another pen, coming back again. You know, this was the technology. Paper and pen was a technology at that time. I'm talking about late 90s, early 2000. But gradually, the technology has started to come aboard and start to change. Towards the end of my time in Eurostar, instead of paper and pen, they have this called PDA, a small devices where things ready, you don't have to print. It's already in this handheld thing. And you have to, all you need to do is just, basically this small machine replace the paper. And you just recording down what you observe. And when we observe this, doesn't mean that that's it. We also have to send back to the so-called the office. The office has to plan for something. Oh, this, let's say, light bulbs gone in the interior of the train. So my task is only walking through and recording only. When I say paper and pen is, I have to walk through the entire trains and then come back to the office, then pass to the office people, and then they plan for the next team to come in to replace the bulb. Just simple bulbs, for example. When we have a PDA, at least it's like, okay, you record everything, is live, you can, okay, that time is not live yet. So you can record this into this, and then you bring back to the office, and then they print out and say, oh, okay, how many light bulbs need to be changed? Gradually, they become an iPad, with Wi-Fi, whatever you recorded, straight away you send to the team. Yeah. Today, the technology is, even before the train arriving at the depot, you know what to do already.
How's that possible?
There will be a monitoring machines along the track or before you reaching to the depot there. So the train will able to start to monitoring what is the issue. So it's a very automatic thing that you can actually start to scan through the health of the trains. What are the things that you need? So you don't even need machine nowadays. There's a certain thing that you may still need so-called people to walk on the ground to look into it. Again, we no longer needed to send people. We send robots.
Robots? Yeah. Can you explain a little bit more about the robots? Because I think our listeners would love to hear about it.
So our robots are being programmed to say that typically things that they need to spot, to check on it. So they look into it, they will be able to zoom, they will take a snap of photos, and they will say that, okay, this is a record. And then straight away, this sends straight away to the office. So again, anything that need to be done in the past, I was saying that I have to send people, I have to record, I have to send back, I have to plan, I have to come back again. This is instantly within 2 hours. Today, I can do 8 hours job. The efficiency have become so efficient that even before the train arrives, I know what needs to be done. I know what parts that I need to prepare and I know which team I'm sending in already. As soon as the train arrives, I can start to send in the first team to do all the repair works. Of course, there are things that are unable to be detected. You still have to send people, but again, now it's being replaced by robots.
That's incredible. So a lot of the train diagnostics actually happens on the fly. Like, even when it's moving, you can tell the health of the train.
Yes.
That is a very cool development. Now, you mentioned autonomous systems. So is machine learning or AI part of this calculus?
So you need to have AI to be able to predict something or to know something, what is considered acceptable or non-acceptable. So these are the things that more data to be feeding into the systems, the AI will start to understand that this is acceptable or non-acceptable. So they already have the data point here. And AI has been like doing in many other jobs as well, So we have, or not say just AI, but interaction. So we are now doing a safety briefing. So when you go to a site, you have to have we call it the health and safety kind of briefing. Basically to tell that, okay, where is the exit, where's the route, do what, where's the safety
Like fire exit,
Fire
and,
exit,
and fire marshals and all that.
any
yeah.
area that you need to be aware of. In Alstom, what we so-called develop now is everything in VR now,
Virtual reality.
virtual reality. So you put on the so-called the VR mask, it's as good as you are on the site, and that is like playing computer games. It will bring you through, walk you through the briefing. So you don't even need to be on site to learn about the site safety. You can be like learning this way before that in the office first. And that saves a lot of manpower as well, because imagine this, every visitor that I have to like sending into the, let's say to the depot or to the workplace, they have to go through this. So I have to dedicate a person just to sitting there to do. Now I don't need any more. All I need to do is just to switch it on, people wire it up, they know what to do.
That's incredible.
Yeah. And the message is consistent. You know, like with people, sometimes group one, I say something, I may miss out something, but this is very consistent because the informations are very visual, and the message is very consistent throughout.
So it's like a pre-programmed tour,
Pre-programmed
like a
tours, yes.
pre-programmed OSHA tour almost.
Exactly, yes.
That's very innovative.
Yes.
So to our viewers out there, remember, these are sort of innovations that industry is looking for. Makes it more efficient, but it's also very exciting, this technology. VR technology is on the frontier of sort of interfacing with the user. So we're going to ask Mr. Sim now what his sort of vision for railway engineering is for Malaysia. He's already covered a lot of interesting and very exciting technologies, you know, hydrogen fuel cell trains, VR technology, right? And autonomous sensors and diagnostic systems. It's something that we don't usually equate with trains. We usually get in the train, we ride on it, and then we just get out. We don't really think much about it, but there's so many innovations packed into one form of transportation. So now I'm going to ask Ms. Sim, what are sort of some of your visions that you have for a sort of more exciting future of railway engineering? Where do you see this going in the next 5 years?
So the railway is going to be a norm in future. That means you can't keep continue building highways, right? Roads. And just because there's more cars and you build more roads, you know, you will never be able to sustain, because this is not the solution, the final solutions. You know, the final solution is like you got to bring people out from the car and take on the public transport. Because as you know, 100 people, you know, like putting on the road, it could be 100 cars. But 100 people putting on the train, the size or the footprints that they are taking is just the size of the trains. So it's actually more efficient, more environmental friendly, more sustainable for the future as well. So it's just a matter of time for Malaysia to have railway in all big cities. You know, minimally all the capital of the states will have a railway. It's a matter of time. It's when only. We see that like 15, 20 years, or even like 10 years ago, metro or railway can only found in Klang Valley. Okay, now in Malaysia, about 2 years ago, Kuching, the Sarawak metros, have started to build their own. The government is actually going to tender for the Penang LRT. So you can see already outside Klang Valley, this too is ongoing. You know, of course, there are other state or other city who have to start to show interest. JB, Johor Bahru, is going to be the next one as well. So you can start to see the pattern. Whichever the so-called the big states or big cities, it will be. Usually, you start to build a railway or metro system for any city like, let's say, 800,000 and above. So in Malaysia, okay, apart from a few smaller states, at least half of our so-called states in Malaysia are reaching that kind of populations. So it's just a matter of time. You know, Malacca can be next, Seremban can be also next, Kota Kinabalu, Kuantan, you know, Ipoh. These are so-called big city enough that can be in the pipeline for the next so-called railway networks. So what I see in future of Malaysia here is just sooner or later, Malaysia with all the states will have a railway network.
That's an incredible future. And I'm sure all our viewers and listeners are also excited for that future of Malaysia, where all the different cities are connected and have easy access to mass rapid transit. I mean, this is the goal, right? And remember from our second segment today, Mr. Sim also mentioned that, you know, as an engineer, you also have to think of the socio-economic impacts, right? And even though the HSR project, you know, is on hold or whatever it is, the most important lesson from that case study is actually that having all these rails and having all the stations and connecting people can lift the standard of the nation and can actually provide people with more opportunities, right? And this is what we're talking about. When you go out to work in industry, you're not only contributing to your organization as an engineer, you're actually contributing to the greater world around you. And so whatever it is you do, whether it's connecting with people or building good teams, remember that the environment and the socio-economic factors have played a really huge role in making the nation where it is today. So we'd like to thank once again Mr. Sim for sharing his insights, not just with what he's done in his many years in the industry, but also his vision for rail systems and engineering in Malaysia as well. Engineering thinkers, it's time for our parting message. First of all, on behalf of everyone on the crew here, we'd like to thank Mr. Sim for taking time out of his very busy schedule to talk with us and to share with us his insights about his experience, his inspirations on his engineering journey. And also he shared some very interesting and exciting developments in the world of AI and rail and green tech as well. So remember, go through the episode again and really pick up some of the incredible tips he shared with all of us. And it's been a very illuminating episode in that sense. Now, I also want to make time to thank our excellent media partners, MMM Group Berhad, which without them, the show and production would not have been possible. So thank you very much to MMM Group. Their crew here is fantastic. They really look after us. Always remember, before we sign off, we have this message to all of you, which is, greater engineer,
Greater world.
Thank you for joining us and see you in the next episode.
Engineering thinker, I hope that you enjoyed today's sessions and my sharing will be able to inspire you to become a greater engineer. Remember, engineer is not just about problem solving. It's about a wider skill set here. We're involving in social, environmental, and even people's management skill as well. So do not just stop at the technologies or problem solving, but look at the wider picture. I hope you're able to learn a thing or two from today's episode and you're able to use it in your future. Thank you so much.
Hello, engineering thinkers. Thank you for joining us in our program today. We'd like to invite you to like, subscribe, hit the notification button, and also follow us on our other platforms such as Buzzsprout, Spotify, and Apple Podcasts. The links for all those will be in the description below. Thank you very much for joining us for this episode, but we have so much more planned for you. So make sure you don't miss out on exciting guests and topics to come. Cheers.